and get on to Chapter 2 in Unit 10, our objectives today. I will be able to fit a regression line to a scatter plot. I will find and interpret correlation coefficients, and I will make predictions based on best line of fit. Here's my vocabulary today. Make sure you review that in the textbook before moving on with the video. Okay, example 1. Find the equation of the linear regression line for Rachael's scatter plot in example 1 from the first lesson. Now, I will tell you that we kind of already cheated because we already figured this out when we were in the first lesson. And let's go ahead and just remind ourselves. So if you pull out your calculator, and you can see that the values that I have in here are the same values that we had from yesterday, or from 10.1. So remember, that was where Rachael was selling water bottles based on the temperature. So I've gone ahead and re-entered it. Remember, we also need to go then to our window, and we're going to make sure that we get our window correct. So when we check on the window, sorry guys, it's giving me a little bit of grief. Checking on our window, we can see that our X minimum is 50, X maximum is 120, Y minimum is 90, and Y maximum is 250. Remember, we set it that way because it's just below the lowest X, just above the highest X. It's just below the lowest Y and just above the largest Y. So then we graph it and we look like this. But now it's asking us to create the linear equation, which we actually already jumped ahead and did yesterday. So you're going to click on your stat button, which again is 1 down from your second button, across 2 from your alpha button. You're going to go 1 over to calculate and down to number 4. And if you'll remember right, here's the equation that it gave us. So when we wrote that equation, we rounded a little bit and we got y equals 4.44x minus 187.67. And that was using our linear regression in the calculator. All right, for the first you do, go ahead and press pause for a moment, solve that, and come back when you're ready. All right, let's go ahead and look at this first you do. Hopefully you've already entered these values into the calculator. You can see that I have here, I've got for my list, all of my X values for list 1, which is 1, 2, 4, 3, and 5. For list 2, I have 56, 45, 20, 30, and 9. I'm going to go in and change my window. So if I look at my window, I've got it set from 0 to 7 because I've got 1 to 5, and I've got it 0 to 75 for my Y value because it's 9 to 56. Now if I look at the graph, you can see it's a pretty straight line of depression, or it's a negative correlation. Clicking on my stat, going over to calc, and here to linear regression, and I get the answer y equals negative 11.9x plus 67.7. All right, example 2. Interpret the slope as for Rachael's linear regression line in example 1. So if we go back to example 1, we see that the slope is the 4.44. So in interpreting that, basically, remember our slope is the change of x, change of y over the change in x. And so by interpreting it, the slope represents the rate of bottles per degree. So for every 1 degree it's going to make 4.444 bottles, and I'm going to round that to 5 bottles per degree. All right, approximately how many more bottles will you sell if the temperature increases 2 degrees? Press pause, solve this, come back when you're ready. Okay, so as I said, we're going to round it up to, the slope was 4.44, and we rounded it up to 5. So for 2 degrees, it's going to increase 9 to 10 bottles. And I say 9 because if we take the 444 and multiply it by 2, we get 888, which rounds to 9. So I'm looking anywhere from 9 to 10 bottles if I round it up to 5. Example 3, Rachel is stocking her concession stand for the day, in which a temperature is expected to reach 106 degrees. How many water bottles should she pack? Well, we're going to start with our formula, y equals 4.44x minus 187.67. It gave me a temperature, which is my x value, so it's as simple as plugging it in, 106 degrees for x. Now, if I work that through on the calculator, we're going to get 282.97. So she should bring or pack 283 bottles. How many bottles should Rachel pack if the temperature is 83 degrees? Is this an example of interpolation or extrapolation? And round to the nearest integer. So go ahead and press pause, solve this, and come back when you're ready. Okay, looking at it, our formula y equals 4.44 times 83 minus the 187.67. When I plug that in, I end up with 180.85. So it's going to be 181 bottles. And it's an example of interpolation, because if you'll remember from your vocabulary, interpolation happens when it's giving you a value of x and asking you to solve for y. Extrapolation is if it gives you a y value and asks you to solve for x. All right, last example here, and let's get started. It says, find the correlation coefficient to the nearest hundredth for the linear regression for Rachel's data. Interpret the correlation coefficient. So in order to do this, let's go back to our calculator. We need to do some special things on here before we can do this. Now, this is something you only need to do once, so once we've got this done, you'll never see this again. What I need you to do is click on your second key, which is the yellow key, and then you're going to click on your 0 down here at the very bottom, and a catalog is going to come up. I need you to hit the down arrow on the calculator until you find diagnostic on. And you'll see it looks just like that, diagnostic on. You're going to hit enter and hit enter again until it says done. Now we're going to go ahead and click on our stat. And it says, find the correlation coefficient to the nearest hundredth for Rachel's data. So the first thing we have to do is actually re-enter our list information from problem 1. So go ahead and press pause and do that, and then come back when you're ready. All right, now that we have the correct information back into our lists, we're going to go ahead and go to stat. We've already turned our diagnostic on. We're going to go to the right where it says calc and down to our linear regression, just like we did in example 1. Only now that our diagnostic is on, you're going to see a couple of extra lines there. And when we're looking at it, we've got our r and our r squared. And our r is what we're actually interested in here. So our r is 0.97. And so it's always going to be a coefficient between -1 and 1. It's always going to fall somewhere in between -1 and 1. So we need to know some parameters before we can really answer this question. So you should know that if the coefficient is near 0, then that means there is little or no correlation. If the correlation is greater than 0.75, there is a strong correlation. If it is less than 0.25, and actually I'll change it, if it's less than 0.3, then it is a weak correlation. And anything else? Is a moderate correlation. Meaning it might have a little bit to do with it, but it is not a direct cause. So if we look at our correlation coefficient here, we see that it is a 0.97. And 0.97 is greater than 0.75, so it has a strong correlation. Now, as to whether or not the correlation is positive or negative, has everything to do with, is this positive or negative? And in this case, no negative sign in front of it, so it is a strong positive correlation. All right, go ahead and put in your new data into the calculator. Solve this, press pause while you're doing that. Come back and we'll finish it together. All right, for this last example, we've got the last bit of data in there. Hopefully you took the time to do that. So you can see it asks you to do it from the check your understanding for example 1. So I've gone ahead and relisted those in here. Again, we don't have to do the diagnostic step again because we've already done that. So once we've got that in, let's go ahead and click on Stat. Sorry, we've got our alpha in here. Got to get rid of that. So 56, go ahead and hit your Stat button. Go over to your Calc button and down to your Linear Regression and press Enter twice. Now I want you to notice here on this particular one, the answer for R is actually negative 0.997. So there's two things to look for here. Number one is there a correlation? And in this case, 0.997 is greater than 0.75. So there is a strong correlation. And in this case, it has a negative in front of it, so it is a strong negative correlation. And that's it for this chapter. Good job, everyone.